Hi there, this is Jacob Nash, Precalculus Lessons, and this is Unit 0, Lesson 7 on the constant problem, as I call it. But this is actually the last lesson of this unit, even though I said that it might be the last one on number 4 or 5, whatever it was. So, this is a problem, that's not the official name for it. Like, I'm not sure what it's called, what they usually call this problem, but I just know that it's a standard that you need to know, so let's see how to do it. And I'm gonna say it's kind of annoying, but once you get the hang of it, it looks crazier than it is. So hopefully this will help if you maybe have seen it, but you don't understand how to do it. Here's how. So there's really only 3 steps. They just kind of take long. The first one, to me, is the easiest. You plug in values into the equation. The equation that you plug values into is this, and this is what you would plug into it. Then you need to simplify. Basically, you just simplify. That's what steps 2 and 3 are. So the problems will always be worded like this. If f of x equals something, it might not be f of x. It could be g of x, z of x, whatever. Something of x equals something. What is the simplified expression for some constant p is not equal to 0, and it might not always be p. It might be a different letter, but usually p, using this. Try to circle it. This right here. Okay? So, if that sounds like gibberish, fine, good. But basically what you're doing is what I said above. You just plug in f of x into this equation, and then you just simplify. That's all you're doing. But it just kind of takes a long time. Now, something to take note of, if you see right here, f of x plus p, what that means is anytime you see x in the f of x for that part, you need to replace x with x plus p. So, there's really 3 parts of the equation that we're going to plug in for. Well, really only 2, because you just have p on the denominator. So let's go ahead and put p on the denominator. So now, we'll start out with the f of x plus p part. That means, for this, we write down this equation, but anytime we see x, we make it x plus p instead. So, instead of x squared, x plus p squared. And if that happened to be like 2x squared, then you would put the 2 out here, but it's not, so. Okay, this thing's a little bit messy today. Then minus 5x, we instead do minus 5x plus p, then plus 3. So that was just that part. So that's pretty easy. Now we have this part, minus f of x. This means we just put minus, and then we write down this, but make sure it's in parentheses because you're going to be distributing that negative. So that part's a little bit simpler maybe because you don't have to do x plus p. So you basically just wrote f of x 2 times, but you just made x plus p on that part. And then in the denominator we have p. So that's the first step, which, like I said, is pretty much the easiest one. Now this one is probably the hardest one, number 2. We simplify the numerator. So that means we need to make this not in like factored form. So let's start out with this right here, the x plus p squared. Now, what x plus p squared is, well, it's not this. Make sure you don't think it's that. Because it's actually this. Right here. And we can use the foiling method, which, like I've said before, I can't go into detail about how you do that because that's something you should already know. But it's the acronym for first, outer, inner, last. But there's actually a shortcut method to do that. A shortcut to know how to factor something like this, and it only works if it's something that's squared. You start out with distributing the squared, and we see that we have x squared and then p squared. And I said that's not what it is, and the only thing that we're missing is the middle term. And how do you know what that is? You multiply the two parts, the two terms, which is x, that x times p is xp, but you double it, so 2xp. So that's what you do. So that method, if it didn't make sense, then just stick to foiling. But I can try to explain it one more time quickly, because it's not what this lesson's even about. But an example with like actual numbers, if you had this, for example, you start out by making that squared, so that's 2x squared. Then you multiply the two terms. 2x times 3 is 6x, and you double that, so plus 12x. And then you square that part, plus 9. So that's the same, we would get the same answer if we FOILed. But yeah, that's basically how you can do a shortcut, because sometimes that is a little bit annoying. So that's just this. So this, we can tell the numerator is going to be pretty long. We don't actually need these parentheses. Now we distribute this negative 5 right here, so negative 5x minus 5p. Then we have this plus 3 here. Plus 3. Okay, that's only this part that we did. We need to still simplify this, which luckily all that means is we distribute the negative, and when you distribute a negative, that just means it changes the sign. So negative x squared minus plus 5x minus 3. Now all of that is divided by p. That's the second step. The third step is basically just we combine like terms or cancel things out. And so let's look at our like terms. Now you won't be able to do this on an actual like test because you don't have like colors, but we see we have an x squared here. We have a negative x squared here. And then we have a positive 2x. Is there something to go with that? Yes. So x here. There's an x here. Oh, sorry, that's actually xp, the first one. So we have x is there. xp has to be by itself. So we have an xp. There's no other xp's. P squared. There's no other p squareds. Minus 5p. There's no other p's by themselves. And then the constants, which have no variables, 3 and negative 3. So, oh, that's not what I want. Whatever. Okay, so we need to now combine like terms or cancel them out. So we see the two blues, they can cancel out because they're positive and negative. So no more, no more. If you cross it out, then it's easier to see. The greens, there's not something to go with the greens. Same thing with yellow, but we can cross out our pinks, positive. And that's not because they're like terms. That's just because they have opposite signs and they're the same thing. They cancel out. Because negative 5x plus 5x would be 0x, which means nothing. So nothing can go with the orange, and then the red can cancel out also. And most cases, this is what will happen. You'll have a xp, a p squared, and just a p left over. And what I like to do is circle those so I can see clearly which ones are left over. And that's what we write in step 3. 2xp plus p squared minus 5p divided by p. Now, we actually can do one more thing. There's a p in every term. P here, p here, p here, p here. If there happened to be like a plus 1 here, then we couldn't do anything else because there's not a p on that. But since there is a p on everything, we can simplify. So, since this is just p right here, that really means there's only one p to the first, so that means 1p. P to the second means 2 p's, p times p, and then 1p here, 1p here. To cancel them out, you take away 1 from every group until you can't take the same amount away from each one. So, goodbye there, goodbye, goodbye, and then only take 1 from there. So that means we have no more p here, no more p here, no more p here, and only 1p left there. So that gives us 2x plus p minus 5. And that is the answer. So, there you go. That it's not really that much work, but it's can be a little bit crazy. So hopefully that made sense. But that will be it for this video. Thank you for watching, and I'll see you in the next unit.